हेलो दोस्तों, कैसे हो। मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं।
The topic is design of Cotter Joint. No, no. With this background of what is induced stress, what is permissible stress, what is factor of 50, what is yield stress, and how do we design a particular part, we will start design of Cotter Joint. Now, now how many parts are there? There are three parts, and what are the parameters? See, D. So you can count D, D1, D2, D3, D4. Then T, T1, C, B, A, 10. So we have to design this 10 parameters. And 11th is length. So length is not found by some value. I will tell you afterwards. So we have to find this value of this 10 parameters. Okay, after we get the value of this 10 parameter, we can say that we have designed a Cotter joint. So we'll start one by one. Number one, design of rod or rods. So considering failure of rods in tension. Now you may ask me, sir, why tension only? I told you this is a joint which is subjected to pull force. This is a joint which is subject to pull force. So it is pulled from both the ends. So if I pull it from both the ends, let us think about this rod. What will happen to this rod? Okay, so this part I have removed. So this is the rod. This is pulled from this side as well as pulled from the other side. It is pulled from both the sides. So since it is pulled from both the sides, it will fail in what? Tension. That's why I am designing the rod. Understand the words. I am designing the rod considering it in tension. I am designing the rod, matlab I am finding the dimension of the rod. Which dimension I will find? Rod is circular, so diameter. So I am finding the diameter of the rod by considering it in tension. So if this is a rod, and if I apply force like this and like this from both the ends, and this is the cross section of the rod here. What is this? D. So what I will see after it fails, what I see? I will see a circle like this, and this is the cross section from where failure has occurred. This is what? This is D. So what is the area? Area of failure equal to A equal to pi by 4 D square. So from this I can write, I know stress equal to load upon area. So I will not write this formula here after. Okay, you have to remember this. That's why load equal to area into stress. So I can write load. What is the load? P equal to pi by 4 d square into what is the stress? Sigma t. So from this equation, we will obtain the value of t. Is this clear to all of you? This one is called as failure sketch. This is called as failure sketch. Failure sketch. Okay, we'll move on to second is diameter of spigot. So here design of rod or diameter of rod is capital D, sorry small d. Here this is D2 and thickness of cotter which is denoted by T. So these two things we will find now in the second formula. So coming to this sketch, see, when this rod is subjected to pull force, we are pulling the rod like this. Rod is subjected to pull force. That time, this rod and this spigot is one material, and it is one part. So when I am pulling the rod, that time the spigot is also pulled. when I'm pulling the rod, that time the spigot is also pulled. Spigot भी खींचा जा रहा है. How? You can see it here. What I am doing is I am pulling the rod. See, I am pulling the rod. So because of this, what is happening? Because of this, the spigot is also pulled. Spigot भी खींचा जा रहा है. So the spigot is also in tension. Have you understood this? You can see it here. This is the spigot, the blue color. This is pulled from this side. This is pulled from this side. So when this is pulled from this side, this entire spigot is pulled in this direction. In this direction. At the same time, this socket, which is pink color, this socket is pulling the socket in this direction. In this direction, and because of this collar, this spigot is pulled in this direction also. It means the spigot is pulled in both the direction, towards the rod and towards the rod of the socket. The spigot is pulled in both the direction, towards the rod of the spigot and towards the rod of the socket. So the spigot is also in tension. Also, the socket. What about socket? Socket is also in tension because it is pulled in this direction because by this rod, like this, and it is also pulled in this direction here. Here also it is pulled. So it is pulled from this side as well as from this side. So socket is also in tension. The socket and spigot both are in tension. Socket and spigot both are in tension. Now if spigot is in tension, similar to what we did for socket, how will you find the diameter of spigot? For that, we need to draw this equation. We need to write this equation, and for writing this equation, what are the things that we need? Load. Do we know the load? Yes, load is P throughout. What is stress? Stress is sigma T. And what is the area? No, that is what we have to go, we have to find. What is the area? So if I draw the spigot here, spigot looks something like this. Now when spigot will fail, from where will it fail? Any part will always fail from the weakest cross section. From the weakest cross section. This is like this. And which is the weakest cross section here in the spigot? Where the material is less. And where the material is less, the material is less this here across this. So this is the plane. This is the plane through which this spigot will fail. Through this plane like this. And when it fails like this, how you will see it? It will be seen something like this. It has failed from here. Are you able to visualize this?
Yes, sir.
It has failed from here. And if I draw it in 2D view, how I will draw it? I will draw it something like this. And this is one line, this is another line, and it has failed from here, as well as here. And what is this dimension? This is what? D2. What is this dimension? This is what? T. So because of this, what will be the area? I can write area equal to, if this is not the failure part, if the entire part is failure, then what will be the area? Area will be pi by 4 d2 square.
D2 square.
Correct. Pi by 4 d2 square, that is the area of the entire circle, and minus this area, this one, which is not subject to failure. So this you have to subtract. We will say that, sir, this is like this. This is curved from here. This is curved from here. So this is not a rectangle. This is not a rectangle. Yes, you are correct. This is not a rectangle. But then for design purpose, we will ignore this portion and we'll consider it as a rectangle. Okay, we consider this as a rectangle like this. So when you are designing, we will ignore this thing, and this area will become d2 into t. Minus d2 into t. So this is the area. So what is the formula now? P equal to pi by 4 d2 square minus d2 into t, and this entire thing into what? Into sigma t. This is the this will give us the diameter of spigot. This will give us diameter of Spigot.
But sir, the condition is we have to know the value of T.
Yes, correct. This will give us the diameter of Spigot, but then there are two unknowns and there is only one equation. So what we are doing here is we are taking T equal to d2 by 4. This is what? This is empirical relation. I told you in the first or second lecture that some designs are made using empirical relation. So this is empirical relation, that the thickness of the cotton is generally d2 by 4. That is empirical relation. So someone may say that, sir, you are taking d2 by 4, I will take d2 by 3. Someone will say I will take d2 by 4.5. Yes, you can take whatever you want, provided we have to check it. We have to check it. Okay, so we will check this afterwards, whether this T is equal to d2 by 4 that we have taken is correct or not. Now understand that you do not have to buy out any formula. See, this basic formula is the same. What is it? Load equal to area into stress. Is there any student in the class who don't know what is the diameter here? How to find the area of the circle? Each one of you know it is pi by 4 d square. Each one of you know this formula, load equal to area into stress. So each one of you can write this P equal to pi by 4 d square into sigma t. Coming to the second formula, this is Spigot. All of you have seen Spigot. Spigot is like this, and there is a slot. When this fails, you get a shape like this circle, but the entire circle is not subject to failure. There is a slot in this which is not subject to failure. So what will be the area? Pi by 4 d2 square, the entire circle area, minus the area of the slot, that is d2 into 2. Sorry, d2 into t. So p is equal to pi by 4 d2 square minus d2 into t is the area into sigma t. So no need to buy this formula. You have to remember this sketch and write this formula. Now, third, what will we do now? We will consider failure of Cotter in crushing. Consider failure of Cotter in crushing. Now understand that. Understand that this Cotter, where is it? It is inserted in this spigot. All of you can see me. All of you can see this Cotter in this spigot. So this Cotter is inserted in this like this, and we are applying force. How are we applying the force? We are applying force. See, this hand, my right hand is applying force in this direction. This direction, and with this hand I am applying force in this direction, opposite direction. Can you see? On the Cotter, the force is applied in both the direction. In one direction by this hand, and in other direction by this hand. Actually, by one force is applied to this rod and other force is applied to this rod. So I have removed it out, and so I am showing you like this. Okay. Now consider this portion of Cotter. This much portion of Cotter. Where is this portion of the Cotter? This portion of Cotter is in the spigot. This portion of the Cotter is in the spigot. Where? See, spigot, Cotter. The portion of the Cotter, this portion of the Cotter you can see. This portion of the Cotter you can see. But there is portion of the Cotter which we cannot see. Where is it? It is in the spigot. And it is pulled like this. So what is happening here? This portion is subject to force like this. It is subject to force like this. Entire Cotter is not subjected to compressive force. Only this portion of the Cotter is subject to force. क्योंकि ये इसके कांटेक्ट में है और इसको मैं ऐसे खींच रहा हूँ, एक हाथ से इधर, एक हाथ से इधर, like this. So this portion of the Cotter is subjected to what? Is subjected to crushing. Now understand, I am saying crushing. The entire Cotter is not in compression. Only this portion of the Cotter is in compression. Because of this compression, this part will subjected to crushing. Will be subject to crushing. So there is crushing of only this portion. So if I draw it here, I can show you like this. This is the entire Cotter, out of which this portion of the Cotter is subjected to crushing. What is this dimension? This is T. What is this dimension? This is in what? This is into the spigot. And what is the diameter of spigot? D2. So what is the area now? Area is D2 into T. So I can write P equal to area into stress. Which stress? Crushing stress. Now understand here, P is known to us, sigma C is known to us. This is given in the question, or there are ways to find it. I will tell you how to find it. Right now, understand that it is given in the question. P is known to us. D2 we have already found here. Here we have already found D2 and T. So we know everything. We know everything. So instead of again finding or re-evaluating the value of D2 or T, what will we do? We will find here sigma C induced. See, sigma C का वैल्यू हमको कहाँ पे मिला है? क्वेश्चन में हमको वैल्यू दिया है सिग्मा सी का. Let us consider that the value of sigma C given in the question is 100 न्यूटन पर mm स्क्वायर. ओके, अभी हम वो वैल्यू यूज नहीं कर रहे हैं, उसको बाजू में रखते हैं. Considering that we don't know the value of sigma C, we are again finding the value of sigma C. So this is what? This is induced sigma C. Because of this force here, this is the area which is subject to crushing. So how much stress is generated? That is called as induced sigma C. So that can be found. It is P upon D2 into T. Now this value of sigma C that we'll find. Suppose, for example, I will take in terms of numbers now. Sigma C induced is coming out as 100 and sigma C permissible. Permissible का मतलब क्या होता है? जो क्वेश्चन में दिया है हमको is 120. Obviously Newton per mm square, Newton per mm square. So will the material fail or not?
No, sir. It won't.
It will not. इंड्यूस्ड हो रहा है, उसमें जो फोर्स हम लगा रहे हैं उसके वजह से जितना उसमें स्ट्रेस इंड्यूस हो रहा है, स्ट्रेस उसमें जनरेट हो रहा है, वो कितना हो रहा है? 100. और वो कितना बेयर कर सकता है, कितना सहन कर सकता है? 120. ओके, सो इट विल नॉट फेल. इट विल नॉट फेल. क्लियर? It means that the value of T that we have found, the value of T that we have found is equal to D2 by 4 is accepted. This value of T is also accepted. So इसमें क्या हुआ? ये चेक जो हम करना था empirical relation वो भी चेक हो गया. Okay, the things are clear till here. Now this is changed. If this is 120 and this is 100, तो क्या होगा? ये क्वार्टर टूटेगा या फेल होगा. किस में फेल होगा? क्रशिंग में फेल होगा. क्रशिंग में फेल होगा मतलब क्या होगा? यहाँ पे उसका वेयर आउट हो जाएगा, क्रश हो जाएगा, वेयर आउट हो जाएगा. ओके, क्रश हो जाएगा मतलब वेयर आउट हो जाएगा, मतलब खराब हो जाएगा, तो वो उसके कांटेक्ट में नहीं रहेगा, मतलब इट इज कंसिडर्ड एज फेल्ड. सो इस केस में ये जो हमने इंपेरिकल रिलेशन यूज किया था ये शायद करेक्ट नहीं है, या फिर ये जो वैल्यू हमने D2 का फाइंड किया ये इंपेरिकल रिलेशन कंसिडर के वो करेक्ट नहीं है. इन सच केस, if the value of induced stress is more than permissible stress, I will write a point here that the design is not safe and we have to re-evaluate. फिर से find करना है क्या? The value of D2 and T. So what will we do? In such case, we'll again find the value of D2 and T. So re-evaluating D2 and T. तो मतलब यहाँ पर जो हमको D2 और T मिला, ये जो हमको यहाँ पे D2 मिला था और T मिला था, ये हम इसके बाद में यूज नहीं करेंगे. कौन सा D2 और T यूज करेंगे? जो हम यहाँ पे फाइंड करेंगे. तो अभी ये मैं एक्सप्लेन नहीं कर रहा हूँ, ये न्यूमेरिकल में देखेंगे. सो नेक्स्ट इक्वेशन नाउ. नेक्स्ट इज नंबर 4 नाउ. डिजाइन और आई कैन से डायमीटर ऑफ सॉकेट. ये किसे डिनोट किया हमने? D1 से. सॉकेट कैसे टूट रहा है? टेंशन में टूट रहा है. क्यों टेंशन में टूट रहा है? बिकॉज वी आर पुलिंग इट. इसको खींच रहे तो टेंशन में टूटेगा. कहाँ से टूटेगा? यहाँ से टूटेगा क्या? नो, यहाँ पर तो ज़्यादा मटेरियल है, यहाँ पर मटेरियल कम है क्योंकि यहाँ पे स्लॉट है, तो ये यहाँ से टूटेगा फ्रॉम हियर. करेक्ट? फेलियर ऑफ सॉकेट इन tension, we'll better sketch something like this. See, it will be like this, and there will be section lines here and there will be section lines here. मतलब इसका सेक्शनल साइड निकाला इधर से, तो कैसे दिखेगा? द वन विच आई हैव ड्रॉन हियर. एंड व्हाट विल बी व्हाट आर dimensions. This is d1. What is this? This is d2. And what is this? This is t. So what will be the area? Consider there is only one circle, then the area will be pi by 4 d1 square. But you can see there are two circles. Okay, this is the hollow part, this is the hollow part. So this is the hollow part. So pi by 4 d1 square minus pi by 4 d2 square. ये तो हो गया एरिया. ये एरिया किसका हुआ? ये एरिया इसका हुआ. ये एक सर्कल है, दूसरा सर्कल है, और ये दो सर्कल के बीच का एरिया हो गया पाई बाय 4 d1 स्क्वायर माइनस d2 स्क्वायर. और ये एरिया भी हमको सब्ट्रैक्ट करना है. कौन सा एरिया सब्ट्रैक्ट करना है? दिस वन. This area has to be subtracted and this area has to be subtracted. So how will we do that? माइनस मतलब क्या है? ये पूरा रेक्टेंगल है, उसका एरिया हम सब्ट्रैक्ट कर देते हैं माइनस d1 इंटू टी, और प्लस ये एरिया हम ऐड कर देते हैं d2 इंटू टी. सो दिस बिकम्स पाई बाय 4 d1 स्क्वायर माइनस d2 स्क्वायर माइनस d1 माइनस d2 इंटू टी. So this is the entire area. So P equal to pi by 4 d1 square minus d2 square minus d1 minus d2 into t, entire thing into sigma t. And this will give us the value of d1 because all other values are known to us. So how many diameters we have found till now? We have found 1 d, second d1, third d2. We cannot find d1 before finding d2 because d2 पहले मिल जाएगा. d1 के लिए हमको d2 चाहिए. Okay, so we cannot find d1 first. We have to find d2 and then we have to find d1. Now next is diameter of spigot collar. इसको हमने कैसे डिनोट किया है? d3 से डिनोट किया है. ये कैसे फाइंड करेंगे डायमीटर ऑफ spigot collar? इसका सेक्शनल स्केच कैसे आएगा? एक ये सर्कल, दूसरा ये सर्कल. ये क्या है? दिस इज d3. ये क्या है? दिस इज d2. और ये फेलियर है. तो यहाँ पे मैं लिखूंगा कंसिडरिंग फेल्यूर ऑफ spigot collar in crushing. Now see how crushing and why crushing. This is spigot, this is socket. Okay, how is the assembly? ये इसमें गया. ठीक है. Can you hear this sound? This is the sound of spigot collar resting on socket collar. Spigot collar resting on socket collar. अब यहाँ पर अगर ये collar नहीं रहेगा, what will happen if there is no collar? There will not be any sound like this and this will go inside. Spigot will go inside the socket. जहाँ तक जा सकता है उतना जाएगा. ठीक है. But this collar is preventing spigot collar और socket collar का जो portion contact में है, it is preventing that the spigot to go inside. और अंदर नहीं जा सकता, बस यही तक आ सकता है. So if you see from here, this is socket collar. This is socket collar. इस socket collar पे वो spigot collar आके रुकता है. It stops against this. और if I show you the spigot collar, this portion of the spigot collar, ये तो spigot है, ये collar है, इसका diameter ज़्यादा है d2, इससे d2 ज़्यादा है. तो ये surface, this surface is subjected to crushing. The one I have shown you in the sketch. This is d3, this is d3, this is d2, d2, d3, d3, d2, और इसके बीच में का ये जो एरिया है, this one I have shown you there, that is subject to crushing. And that's why I can say here area equal to pi by 4 d3 square minus pi by 4 d2 square, and I can write the formula P equal to pi by 4 d3 square minus d2 square in bracket into sigma c. Sigma c. Sigma c. Here we will get the value of d3. So this is giving us the value of d3, and now we are left with only one diameter, and that is d4. तो देखते हैं d4 कैसे फाइंड करेंगे अभी. So I will write next diameter of socket collar, and it is denoted by d4. It is denoted by d4. Now the socket collar diameter can be obtained by considering failure of socket collar in crushing. Now understand how this happens. Failure of socket collar in crushing. See, this is socket. This is socket. And which is socket collar? This one is the socket collar. And this is the cotter. This cotter is inserted like this. Now is the cotter touching the socket collar? You can see this gap. Okay. But if it comes like this, okay, now the socket collar is in contact with the cotter. Okay, socket collar is in contact with the cotter, and the cotter is pressing against the socket collar. Cotter is pressing against the socket collar. Can you see this? The cotter is pressing against the socket collar. पुश कर रहा है सॉकेट कॉलर को कि सॉकेट कॉलर से टूट के ये बाहर आ जाए. See, something like this. It is trying to press such that it wants to come out of this. It is pushing it. Okay. Because of this, what happens here and at the bottom, at two places of the cotter, there is crushing. I will draw it here. Show it to in this sketch. See, this area of socket collar and this area of socket collar is in contact with the cotter. Okay, this one and this one is in contact with the cotter. So if I show it to you in this view, it will be from here, यहाँ से लेके यहाँ तक. And in this view here, if I want to show you, it's like this. So this is the area of socket collar or cotter. You can say either socket collar or cotter, क्योंकि दोनों का crushing हो रहा है. You can see both are being crushed here. So this area is subjected to crushing. So how will you draw it here? In order to draw it, I showed you in the side view. So it will be like this. This is the entire cotter. इतना cotter में से देखो कहाँ पे टच हो रहा है ये? This is what? D4. This is D4. From here to here is D4. This is D4. और कहाँ तक टच हो रहा है? Till D2. This is D2. So this is crushed and this is crushed. और इस दोनों के बीच में एक सर्कल आएगा D1. So you must have seen that I have not drawn it through the dotted line in that sketch. So this D1 is there. So ये D1 के भी नीचे crushing हो रहा है यहाँ तक. So what will be the area now? Area is very simple to write. Okay. Area is equal to D4 minus D2 into T. T is the thickness. So I can write the formula P equal to D4 minus D2 into T into sigma C. This is the formula, and from this formula I will get the value of D4. I will get the value of D4. So till here we have found all the diameters. Now we will find the A, B, C and T1 values. So I hope all of you are with me. I am not sure how much are you understanding here, because this is a online class. कितने students को समझ रहा है, कितने students को नहीं समझ रहा है, I don't have any idea, because I am not getting any questions or not getting any acknowledgement that okay sir we are understanding or something like that. So I consider that it is understood to each one of you. You can watch this video afterwards also, so that if you have any doubt you can understand through the video and you can ask me afterwards. So we have found now the diameter of socket collar also. Next we will find now the other parameters. Now all other failures are in shear. Now all other failures are in shear. So to understand how it fails in shear. See now, you can see this sketch, this A, then this B, then this C, and this T1. A, B, C and T1. All this fails in shear. So up till now we have found how many values? We have found D, D1, D2, D3, D4 and T. We have found 6 values up till now. Now we'll find the next value. See now, we'll start with B first. B is the easiest of all. If you understand B, then others are easy to understand. See, this is the Cotter. So I will write here failure of Cotter in shear. So this Cotter is now subject to shear failure. See how the Cotter is like this. You may not see the taper properly here. This is pulled in this direction here, and this is pulled in this direction and this direction. Here the force is P. Here it is P by 2 upward and P by 2 downward. This is Spigot side and this is socket side. So because of this, what is happening? This, where is the Spigot? The Spigot is like this. The Spigot is like this. And where is socket? Socket is something like this. This is the part of the socket. Something like this. Okay, there is socket and there is Spigot. The Spigot is pulling it in this direction and socket is pulling it in this direction. Because of this, what will happen? At this place and at this place, there will be failure of Cotter, and that will be failure in shear. So if I draw it like this in the 3-dimensional view, then you can see its failure something like this. How many places we can see the failure? This is one place, this second place, and this is one more place which we cannot see from this view, and this is one more place. So here there is a single shear, and here there is a single shear, and these two single shear makes it a double shear. So what will be the area now? Area equal to, what is this area? What is this area? This is what? B, and this is what? This T. So area is equal to B into T for single shear. For double shear it is 2 into B into T. So I can write P equal to 2B T into tau. This is the formula, and from this you will get the value of D. You will get the value of D. Okay, so we have seen how to find the value of B. Now we'll see how to find the value of A. A is this. So this Cotter, if it fails, then this is the Cotter. How many pieces or how many pieces there? A piece is this. This is one piece, single piece. When it fails, it will fail in how many pieces? It will fail in 3 pieces. It will break from here, and it will break from here, here and here. So this portion will go like this, and this portion will go like this, and this will go like this, and this will go like this. So we'll get 3 pieces of this. That is failure of Cotter in shear. Now the next is 8 number. What we have to find now? We have to find the dimension A. So I will write failure of rod end in shear. Failure of rod end in shear. What is this rod end? I will draw the sketch again so that you will understand what is this. See, the Cotter spigot is like this. This is the spigot. There is a slot here, and this distance is A. Which distance is A? This distance. So this is called as rod end. This end is called as rod end. Now what will happen here? Because of this Cotter in this rod. Now this Cotter wants to come out of this rod. It wants to come out of this rod. See, this Cotter wants to come out of this rod. How will come out of this spigot? How will it come out? In order that this rod Cotter come out of this spigot, it needs to break this. इसको तोड़ना पड़ेगा. It needs to break this. Then only the Cotter can come out of this. And why the Cotter wants to come out? Because it is pulled by the socket at other end. Socket इसको खींच रहा है other end से. So socket खींच रहा है तो इसको क्या करना चाहिए? इसको ये तोड़ना चाहिए, उसको बाहर आना चाहिए. So that is what this Cotter is trying to do. Okay, so when this is trying to do this, it fails the rod end in shear. And how it will fail? It will fail something like this. So from where it will fail? See now. Let me erase this. It will fail from here. This and this. Because this Cotter has to come out from here. So how it will come out? It will fail from here. Like this. After this failure, what will be left? What will be left? See. This will be left like this. This. See, this is how will be left. Now this time the failure has happened from here. From this side as well as from this side. And the part that will come out like this. What is this dimension? This dimension is A. What is this dimension? This dimension is D2. So what will be the area now? Area is equal to A into D2. It is double shear, so 2 into A into D2. So I can write P equal to 2A D2 into tau. This is the formula, and from this we will get the value of A. We will get the value of A. Is it clear to all? Just seeing the chart and putting yes will put no. Of socket collar in shear. This will give us the thickness of socket collar, and that we have denoted by C. Now understand that to find thickness of socket collar, see, I told you this earlier that the Cotter is inserted like this, and the Cotter wants to come out of this. The Cotter wants to come out of this. Why it wants to come out? Because the spigot is pulling it like this. So how it will come out? It will come out by breaking this. So for example, this is the Cotter. It is inserted here, and it is pulled like this. So when it is pulled, what it will do? It will come out of this, and in the process it will break this. Can you see this? इसको तोड़ के बाहर आ जाएगा. ये पूरा राउंड था, अब इसने तोड़ दिया और ये बाहर आ गया कॉटर. तो क्या हुआ है? फेलियर हुआ है. कौन सा फेलियर हुआ है? शेयर फेलियर. कहाँ पर हुआ? कहाँ से टूटा? देखो ये जो यहाँ पे दिख रहा है, ये पूरा कंप्लीट राउंड था, ये पूरा कंप्लीट था. ये यहाँ से टूट के आया. कहाँ से टूटा? यहाँ से. दिस इज द एरिया फ्रॉम वेयर फेलियर हैज हैपेंड, और दिस इज द एरिया फ्रॉम वेयर फेलियर हैज हैपेंड. तो ये कैसे दिखेगा? यहाँ से दिखेगा क्या? नहीं. ये यहाँ से दिखेगा क्या? नहीं. कहाँ से देखना पड़ेगा? साइड व्यू से. दिस इज व्हाट? This is D4. Out of this D4 till D2, that is till this. Here the crushing shear has happened. Here the shear has happened. So what will be the area? And now in this case, this is not T. This is what? C. See, you are looking from here. You are looking from here. So it is C. See, you are looking from here. So that is C. Same formula हमने इसके पहले भी लिखा था. Let me write this first. Area is equal to D4 minus D2 into C. Same formula हमने पहले लिखा था, लेकिन तभी क्या लिखा था? तभी लिखा था हमने D4 minus D2 into T. क्या दिख रहा है अभी? Now you can see this thickness T. अभी ये thickness दिख रहा है ना T. लेकिन अभी हम यहाँ से देख रहे हैं shear failure है. तो ये क्या दिखेगा हमको? ये थिकनेस नहीं दिखेगा, ये डायमेंशन दिखेगा. ये क्या है? C. And since this is double failure, sorry, double shear, so it will be 2 times. So P is equal to 2 D4 minus D2 into C into tau. This is the failure of socket in shear, and from this we will obtain the value of D4. Sorry, we will obtain the value of. So there is one more last formula left here, and that I will explain you now. That is failure of Spigot collar in shear. Failure of Spigot collar in shear. So where is Spigot collar? Spigot collar is, so if I show is, this is the Spigot, and where is the collar? This is the collar. Now this collar is a part of this spigot and rod. It is not a different part. It is 1, 2 and 3. 1, 2 and 3, all these 3 are same part. Okay. It is having different diameter and is named differently. But all this is made up of same material and it's the integral part. No. Assume that spigot collar is like a ring on the spigot. Ring matlab, it will be something like this. When I say ring, so ring will be something like this, this and this. This is ring, and inside you will see it as a rectangle. So this, you can see this is like a ring on this spigot. What happens? Because there is a force acting on this spigot collar. Who is acting the force? Who is applying the force on the spigot collar? The socket collar. You can see now this socket collar is applying the force on the spigot collar. Like this. Can you see? So you will not be able to see in this view. So I am showing it like this. Socket collar is applying force on the spigot collar. Now because of this force, now when this force will be applied, will the force be applied if it is pulled like this? No. When it is pulled, there may not be any shearing or crushing. You can see when it is pulled, there will not be any shearing or crushing because there these two socket collar and spigot collar may try to go away from each other when it is pulled. But when it is compressed, that time they will try to come close to each other and they will exert force on each other. When they will exert force on each other, there can be two things that can happen. One is failure of spigot collar in crushing. This one, failure of spigot collar in crushing. So it may get crushed here. But if it is designed such that it is strong enough in crushing, then it may not fail in crushing. And what other mode of failure is possible? The other mode of failure that is possible is the one which we are discussing now is this. Because of the force exerted by like this on this by the socket collar and the spigot collar, this which is ring shape may come out. And when it come out, how it will look, how it will appear. Just see this. This is the spigot, and on this spigot we have this spigot collar. We have this spigot collar, and this is the rod. Because of the force which is exerted like this on this spigot collar, force exerted on the spigot collar, it may happen that it may come out, and when it come out, how it will be visible to us? Like this, and there is a rod. And where was it mounted? It was mounted somewhere here. It was mounted here, and now it is not the part, and it has come out, and it will be seen something like this. This is the spigot collar which was mounted like this. So this is the part from where, which was here, which was here. So this has come out from this. Now, okay, is it clear to all of you how the shearing has happened? Any doubt to anyone?
No, sir. Clear.
Okay. So if it is clear to you, then this is what, this thickness is T1. And how will we write the area? If I write it here, this thickness is what? This thickness is T1. What is this diameter? This diameter is D2, diameter of spigot. So it has failed from the periphery. You can pay attention here, it has failed from the periphery. What is the area of periphery of one plane? Pi d. That is called as circumference. So I can call it as pi d. So if I have to write the area, it will be pi d. Pi d is the area of the periphery. Since the diameter is d2 instead of d, I will write it as pi d2. So pi d2 is one circumference. अब ये ऐसा circumference कहाँ तक है? From here to here, from here to here. So what is that? T2, sorry, T1. So this is the area, and I can write P equal to pi d2 into T1 into tau, and this will give us the value of T1. So T1 can be found from here. Okay, now after explaining all these failures, there is one last formula that I have to explain, and that is what? That is length of Cotter, and that is equal to 4 times of d, which is Cotter, this is Cotter, and length of Cotter is this L, length of Cotter, and it is 4 times of d.